Okay, so I'm supposed to show that this is equivalent to this system of equations, which you've used matrices to solve systems before. So I can just do the matrix multiplication. Row 1, 2 times x plus 3 times y, and that has to equal 7. Row 2, 3 times x minus 1 times y equals -5. And that's my system. What they're going to do below here is call this matrix A, this matrix X, and this matrix B. To solve this, I could multiply multiply by A inverse. This becomes the identity matrix.
Easier than like multiplying by the B inverse, because then the X and the Y would still be.
Yes. So that gives me I times X equals A inverse B, or X. The XY matrix equals A inverse B. Pretty easy way to do it on the calculator. The first thing it says is write this in the matrix form. Integrated or applied to. ANI2, please keep your voice levels at 1. So what this looks like, to write it in that form, 3, yeah, 3, 2, -1, 1, 1, 1, -2, 1, 0, because there's no Z. So I'm actually writing it in the form it requests before I do that. And then, yes, I'm going to go to the calculator and do X equals A inverse B. On the calculator, you can actually store the matrices too, if you need them for more than one thing. 3 by 3, yes. I'm going to clear this. I've got that matrix on another screen. Three, 2, -1, 1, 1, 1. Oh, those are supposed to be ones.
This is -6.
-2, 1, 0. For the fun of it, I'm going to store it as A.
Same those down.
3. I have to scroll over to go down by 1. Enter. 4, 0, 1. I'm going to start as B. Now I can just do A inverse B. I'm not sure that this is any quicker for this type of problem, but if I need to use them multiple times, storing them can become very useful. So X is 1/10, Y is 6/5, Z is
2 plus 4.
Z equals -13/10. And even any vector ones, you can do vectors as a single column matrix. So you can do a lot of operations on them by storing them and not having to re-enter it every time. Okay, so far pretty simple. Solve using matrices. I think you can do that one. Just put in the matrix. Type it into a calculator as
-1 x times
times
5.
5, 7.
Nothing.
And we justified above why that worked with matrices, which is understanding that will make matrix things go a lot easier. So here we have the members of a chess club are ranked on points awards for winning at various competitions. The table shows the number of each type of competition won and the total number of points. Find the number of points awarded for winning a game in each of the 3 competitions. So, first thing we're going to want to do is put that into a matrix. We can treat it like,
But I was thinking the total points would be the
you can do
20,000,
how many?
like you just put the table in this.
Yes, and you could actually do reduced row echelon form with it as is. But this, the way they're thinking of it, is times points awarded for each type of win equals,
The total.
well, it's the type of points for winning a practice match, a city tournament, or a regional tournament. And we just solve our system. And we get 2, 15, 50. 2 points for winning a practice match, 15 for winning a match in the city tournament, 50 for winning a match at the regional tournament. Which that kind of makes some sense. You could have also done, like you might have done in pre-calc, 27.9 to 289 and done reduced row echelon form.
Oh, that's just timesing it by the 3x3 identity.
No, it puts it into that. Your calculator can do that. So I'm going to show that on the calculator.
No, I can't remember. Then it puts it so that's like 1 0 0 the answer. 0 1 0 the answer.
Yes. So I'm going to show how to do it just in case you forget later. Or anybody else needs this in the future.
I did it by hand in pre-calc. I like.
You will not do it by hand.
Not fully
Doing it by hand is ugly.
sense, but I don't.
It,
Also, it takes like 10
It-
minutes
yeah.
at least.
3 by 4. 27. 9. 2. 289. 24. 8. 1. 218. 35. 50. 51. No. 5, not 51. What that is something to be careful of with matrices, making sure there's enough spaces. So to do this on this calculator, you do menu, matrix and vector is 7 here. Reduced row echelon form. Oops. I guess I'm gonna need to store this. I could have typed it. I needed to do matrix and vector first. Because I needed it inside. But if I store it as a menu, matrix, and vector, same thing. I probably would have done it that way because it was already given in that format. Because it was already like sitting in the table this way. Usually I'm the inverse way, but I'm like when it's sitting in the table, it really wasn't that hard either.
They're gonna do this form too.
Yeah,
It's better than most.
you just had to separate them. So this one, but the nutrition studies, the number of bars consumed by each and the calories noted in the table.
Alex or
Oh, yep. So we'd put them in. Same thing. I would have reduced row echelon form to this one too. Done this 4x5. Cryptography. This is where it gets interesting. This is where it's new.
thing. Like, so,
Matrix multiplication can be used to encrypt. So you can take something like my password 12 and assign it numbers. So notice they've done the alphabet and then the numbers here. And so they're assigning numbers are down here. So the top,
That's just the number assigned to each letter, though.
that's the number assigned to each letter and each number. Notice one has been assigned 27.
Numbers.
Hmm. So A is assigned 1. It's kind of like these two are just an extended long row. They just didn't want to put it out there.
No, I'm seeing it now. I just didn't see the 1 through 9.
So we can write ours, since this is 12 characters, we can write it as a 3x4. Okay, we need to pick something that makes sense. They won't give you ones that are too gnarly or weird lengths. Need to make a, so we take 13, 25, 16, 1. That makes sense. Oh, they put that there.
Like, does it matter where you put which numbers?
As long as you know, I would say go in order.
So it's MYPA on row 1.
Well,
and
what, so they,
then ASS, and then
yes. What they did was they translated everything into this.
1, 2.
They translated them all, and then they went row 1,
Yeah.
row 2, row 3. Now, what shape you're going to do your matrix depends on what your encryption matrix is. So we're going to end up doing E times P. And E is a 3x3, which meant P had to be 3 by something. To get it to 12, that's why it's 3x4. You're going to get given the encryption matrix.
About how that
You're not going to make that up.
someone does, but not me.
Yeah. So the encryption matrix is given to you. So you can multiply and you get this. What they're going to do is send it to you. You get sent this. If I want to decode, so I essentially have EP equals my, we'll call it C for code. If I want to decode, to undo this side, I would multiply by E inverse, which means I need to do E inverse C. And again, I'll never inverse a 3x3. I will always let my calculator do that. If I was doing encoding, I probably wouldn't bother doing that by hand regardless. But okay, given this and the encoded message, show that the original message is that.
So N is the original message? No, M is the encoded.
M is the encoded, I call it C, yeah. P is the original. So what I'm gonna do is I'm going to do,
Times M.
Yep.
Equal P.
That should equal P. And I'm gonna go, I've got it on another screen. And I'm gonna go to the calculator and actually find it.
By P by E again. Or
E by P. It needs to be in the correct order.
3 by.
So I'm just gonna put them both in and save. 3 by 3, 1, 5, 0. And yes, when you write them out, please use capitals. But, the calculator doesn't need to. I'm not. So yeah, I'm storing them because I have this funny feeling I might be using them in the next example too. 3 by 4. Oh, 19, 19, 23, 15, 18, 4, 27. And it had to be in the order E inverse M. So E inverse isn't really to the power of -1, but that's the notation it uses. So and that does not appear to have worked. Did I enter them correctly? I don't think it kept E. Did I enter M correctly? Let's see here. 13, 25, 16, 1, 19, 19, 18, 4, 27, 28. So something didn't work here, so I'm going to re-enter E. 1, 5, 0. I don't know what I hit in the middle that it kind of looked like it cleared stuff. But
So substitute for.
No, so minutes. I have a job about that. Family, like. Yeah. Oh.
oh, I maybe shouldn't have used E. I'm wondering if it's trying to do E, like the number E. Okay, let's just see. Times M. No. What's going wrong? Oh, I didn't enter M, I entered P. Would help if I entered the correct matrix as M.
Exceeded one episode of like, well.
It's very important when you're doing these to enter the correct matrix for what you're trying to get. because if you reverse your encryption on the one, that's made out. Okay, now it worked. If you don't enter it correctly, it will not work. Yeah. So here's my encryption matrix. It wants you to encode HL math 1. So it's 8. It has to be a 2 by. Okay, you're getting me the numbers. 8, 12, 1, 20,
8,
8,
again,
7. So it needs to be, because my encoding matrix is a 2, it needs to be it's 2 by 2, so I have to have a 2
something. More than 2 by 4.
2, yeah, 2 by 4. So
So you can't encode a password that's odd.
you can, you just put a 0 at the end. Because this is odd characters. Wait. Oh, at the end is a space. Blank space. So instead of a 0, they're putting a 37. So it should be 37. So you're just including the blank space. You need a code for that. I'm not sure if 0 would screw it up or not. So I go to my calculator. I'm supposed to encode it. So I'm going to left multiply by this times that. I'm to make this cleaner. I'll probably clear it off. So you can I can read it off my other screen. This time I don't feel like storing them. I'll use the 2 by 2. 2, 1, -3, 7 times menu. I think you can do a matrix through menu. I have to use this 3 by 3 one where I select them. 2 by 4. 8, 12, 13, 1, 20, 8, 27, 37. And I end up with that. That kind of makes sense. Okay, that is the end of today's lesson.